So a tetrahedron of 55 mm sides rests on one of its corners such that an edge containing the corner is inclined to HP at 50 degrees and VP at 30 degrees. Draw its projections. So here, since it is a tetrahedron, so we have four sides has to be equal. So that is AB, BC and CA will constitute three sides, and OA is equal to OB is equal to OC. That will going to become the constitute the fourth side. Now here, since it is resting on HP, so obviously we have to start from HP such that it is resting on corner. So have to have the initial position such that one of the edges is perpendicular to VP. So obviously the edge opposite to that will going to become the corner. So this point will going to be a corner, whereas this point is the edge. So to start with, or to begin with, first you have to draw a triangle of 55 mm side. So draw a vertical line of 55 mm, and then from here with A as center take a radius of 55 and draw an arc, and then again with C as center cut the arc for a radius of 25. Then you are going to get the equilateral triangle. Now to find out the center, from the point B draw a horizontal line which is opposite to that of AC. That means it will be perpendicular to AC. From A, then again you find out the midpoint of BC, which will be 27.5. Then you mark that point. From A you join to that point, so that these two will going to intersect at this point, which will going to form as O1, and join O to C with a dark line, and O to B and O to A. So this will going to form the top view of the tetrahedron of 55 mm sides. Now since AB is equal to BC is equal to CA, which is equal to 55 mm, so that is because, so when you look from the front view, A is near to the observer, so A dash is visible. When B is near to the observer, so B dash is visible, and C is away from the observer, so C dash becomes invisible. So since it is O1, draw a vertical projector from the top view to the front view. Then O1 dash will be at the base, and O dash has to be found out now. So to find out O dash, since OA is inclined to VP, so you are not going to get the true length here. Similarly, OC is also inclined to VP, so we will not be able to get the true length here. So since OB is parallel to VP, so we are going to get the true length. So from you draw a vertical projector from B to the XY line. So then from B dash you take a radius of 55 mm and cut an arc on the vertical projector of O1, so that you are going to get this point O dash. Then join O dash to B dash with a dark line, then O dash to A dash C dash with a dark line, and then A dash to B dash with a dark line. So this will going to constitute, then join O dash to O1 dash with the center line marking. Now once you complete this, now you have to go for the second position where it is resting on one of its corners, which is inclined to HP at 50 degrees. Now to do that, first you consider any point on the XY line, which is, since it is a resting point is the corner, so obviously it should rest on B dash, because B dash is the corner. So once you get the point B dash, then from B dash, then by using the protractor you measure an angle of 50 degree, because so he says it is inclined to HP at 50 degrees, so it's a true inclination. So since the edge OB is parallel to VP, so I am getting the true length here. So on true inclination line we have to transfer the true length. So O dash B dash is the true length. So first from B dash you draw a line which is inclined at 50 degrees to the XY line by using the protractor. Then you measure the length from B dash to O dash. From B dash you draw an arc to cut it on that 50 degree line. Then measure the length from B dash to A dash. From B dash you draw an arc here, and similarly you measure the length from O dash to A dash. From O dash you cut the previously drawn arc to get this point A dash C dash. Then join B dash to A dash C dash, and then A dash C dash to O dash, and O dash to B dash with a dark line. Then measure the length from B dash to O1 dash. From B dash you transfer the distance to get this point O1 dash. Then join O dash to O1 dash with a center line. Once you get this point, then draw a vertical. Then we have to write the top view. Draw a vertical projector from A dash C dash, and draw a horizontal projector from A and C to get these 2 points AC. Similarly, draw a vertical projector from O1 dash, and draw a horizontal projector from O1 to get this point O1, and draw a vertical projector from B dash, and draw a horizontal projector from B to get this point B. Similarly, draw a vertical projector from O dash, and draw a horizontal projector from O to intersect at this point, so you are going to get this point O. Then join A to B, B to C, and C to A with a continuous thin line. Then join between O to A, then O to B, and O to C to complete the views. Once you get this, all these things which you should do by using the continuous thin lines, then you have to apply the condition of visibility. All the exterior edges of the boundaries of the solids are visible. OA, AC, and CO will form the exterior edges of the boundaries of the solid. So you have to dark them. Since continuous dark line, then since B dash is on XY line, so the edge or a corner which is on XY line in the front view is always invisible in the top view. So the B point will going to become invisible. So from the B point there are three edges which is emanating out. One is OB, and the other one is AB, and the third one is BC. Since this is invisible, so naturally BO will become to invisible edge, and BA will going to become invisible edge, and BC will also become invisible edge. So then only from O to O1 you mark that as a center line. Since a portion of ABC is invisible, so O1 becomes invisible. So now then he says that the edge containing that corner is inclined to VP at 30 degrees. Which is the edge containing the corner? The corner is B dash, so the edge containing that is O dash B dash, which is now inclined to VP at 30 degrees. So since in the second position, the edge, once the edge becomes inclined to HP at 50 degrees, then you are going to get the apparent length here. But the inclination given is the true inclination here. So we need to find out the true length. So since it's given the true inclination, so we need to find out the apparent length, because the top view, the second position top view, the edge which is containing the corner which is B dash, which is B dash O dash, is inclined to HP. So obviously you are going to get the apparent length here. But here you have the true inclination. So first you need to find out the apparent inclination. So to do that, first consider any point on the XY line and then draw an inclined line which is inclined at 30 degrees to VP. Then measure the true length of the edge. Since OB is parallel to VP, so you are getting the true length here, which is O dash B dash. Then measure the length from O dash to B dash. From O, you cut an arc on that 30-degree line, so that you will going to get the apex, so that you will going to get the locus point. From here you draw a locus. Then you measure the length from O to B. From O as center, cut an arc on that locus point, so that you will going to get this point B and extend it down. Similarly, you measure the length from O to O1. From O you mark that point, so you will going to get this O1. Once you get this, then with O as center, take a radius of OA. Then draw an arc here. Then you measure the length from B to O. From B you cut an arc on this to get this point A. Once you get this point, then from A you measure the length of A to C. From A you draw an arc. Again from O you measure a radius of OC. With O as center, cut an arc on this to get this point C. Then join all these things, including the visible and invisible edges, exactly very similar, the same, very similar to the one of the second position top view, so that will be repeated here in the third position top view. Once you complete this, then you need to write the front view. To write the front view, draw a horizontal projector from A dash and C dash, and draw a vertical projector from A to intersect at this point A dash. Similarly from C to intersect at this point C dash. Similarly, draw a horizontal projector from O dash and draw a vertical projector from O to intersect at this point which is called O dash. Similarly, draw a horizontal projector from O1 dash and draw a vertical projector from O1 to intersect at this point which is O1 dash. Similarly, draw a horizontal projector from B dash and draw a vertical projector from B to intersect at this point B dash. Now we need to complete the naming. So first you name between A dash, B dash, C dash, and O dash and O1 dash. Once you do that, then join between A dash to B dash, B dash to C dash, C dash to A dash with a continuous thin line. Similarly, join between O dash to A dash, O dash to B dash, and O dash to C dash with a continuous thin line, and join O dash to O1 dash with a center line marking. Then now you apply the visibility and invisibility. All the exterior edges of the boundaries of the solid is visible. So since B dash, C dash, C dash, A dash, A dash, O dash, and O dash, B dash forms the exterior edges of the boundary of the solid, so you dark them with a continuous line. Then when you look from the top, when you look from the front view, ABC is the surface which is near to the observer. which is a triangular surface which is near to the observer. So join between A dash to B dash with a dark line. Since A dash B dash is a dark line, then O dash C dash is crossing that A dash B dash. Since A dash B dash is a visible edge, therefore O dash C dash becomes invisible edge. So then, since A dash B dash C dash is visible, therefore O1 dash is visible. Then join O dash to O1 dash with a center line. So finally, now we can see that a tetrahedron of 55 mm sides of base and having resting on one of its corner, the edge containing that corner makes an angle of 50 degrees to HP and 30 degrees to VP. Since we have considered all the conditions, since we have satisfied all the conditions, hence the problem is right. So,